The last little bit that we need to cover for parabolas, we're going to look at some equations that are not in our standard x squared equals 4py, y squared equals 4px, or with h and k in there. They're not in that format. And we're going to look at how we could get them to look like that so we can graph them the way we know how already. Okay, that's one thing. The second thing is we're going to look at some applications of parabolas, all right, where they're used in the real world. So first one, it says prove that the graph of y squared minus 6x plus 2y plus 13 equals 0 is a parabola, and then find its vertex, focus, and directrix. What clue do you have that it's a parabola if they hadn't said it was? It has a y squared but not an x squared, right? That makes it a parabola. Or if it has an x squared but not a y squared, then it's a parabola. So we can kind of help narrow it down once we know all the different conics. That way, if it's just got one squared term, we know we're trying to make it look like a parabola. So the idea here is we want to try to get it, since it's y squared, we want it to look like y minus k squared equals 4p times x minus h, right? That's the format we know how to work with. So we want to get it to look like that. To do that, we're going to have to complete the square. So your first step is whichever variable is squared, get all of the terms on one side that deal with that squared. So in this case, we have a y squared. We're going to put anything that has a y on the left side, and all of our x's and constants are going to go on the right. Okay? So for this one, the y squared is going to stay on the left and the 2y, but I'm going to move the negative 6x to the other side by adding it over, and I'm going to move the 13 over by subtracting it. Okay, so I'm separating all of the things that go with the squared term from all of the other pieces. Okay, then we're going to try to complete the square because we want this to turn into that, right? Something quantity squared. All right, so it needs to be a trinomial that we can factor down into that. So we have y squared plus 2y plus something equals 6x minus 13 plus something. Whatever we add to one side, we have to add to the other. Do you remember how to complete the square, how to find that missing term? We're going to take half of our b term and square it. All right, so half of this 2 would be 1, and 1 squared is 1. So we're going to add 1 to both sides. Okay. Now we need to factor the left side. So we have y squared plus 2y plus 1. We want it to factor down into that, right? To a quantity squared. What would it be? Okay. On the other side, combining like terms, the negative 13 plus 1 would be negative 12. Now, is it looking closer to what we were trying to get? But in our parabola formula, we usually have an x minus h with a number in front. Could we factor this 6 out? Yes? What would we have left? Okay. Now it looks like a parabola equation, right? It's our standard form for a parabola. So can we figure out the vertex from this? What would it be? Okay, and it's great that you noticed the order, right? We want to put x first, y second. So 2, negative 1 is correct. Let's go ahead and graph that. Okay, that's going to be my vertex. And then what else do we need to know? They want us to find the focus and directrix as well. And so we would need to know P. So in our equation, this 6 is taking the place of what? The 4P, right? So if 6 equals 4P, then P must be 1.5. Okay? Now, how do we know if that focus is 1.5 units up, down, left, right from the vertex? How do we figure that out? Okay, it's a y squared kind, right? So y squareds go to the side. Okay. So y squared kind, and we know that P is positive, bigger than 0. So it's going to open which way? Okay. All right, so we know it has to open to the right. So we're going to go 1.5 units to the right to find our focus. Okay, what are the coordinates of that? (3.5, -1). Okay, and then if we went 1.5 units to the right to find the focus, where do we go to find the directrix? Left 1.5. So from our vertex, left 1.5 puts us here. What's the equation for that? Okay. So that's our directrix. So we've actually found everything they asked us to find. But a quick review, if they wanted us to actually graph this, what else would we want to do? Yeah, we need to use that focal width, right? The chord through the focus. How long is the focal width? It's 6 from our equation, that 4p piece. So if it's 6 long, then we cut it in half, right? We want half on one side, half on the other side. Okay, so we're going to go from our focus up 3 and down 3. All right, that would give us a focal width of 6. Okay, and now we can draw a parabola. Okay, questions about that? All right, our last learning objective deals with applications. It says the main applications of parabolas involve their use as reflectors of sound, light, radio waves, and other electromagnetic waves. If we rotate a parabola in three-dimensional space about its axis, or its line of symmetry, the parabola sweeps out a paraboloid of revolution. If we place a signal source at the focus of that, the signal reflects off the surface in lines parallel to the axis of symmetry. This property is used by flashlights, headlights, searchlights, microwave relays, and satellite uplinks. So look at the first picture here. What they're saying is if we put a light source at the focus here, that light is going to bounce off the edge of the parabola and be directed straight out, parallel to its axis of symmetry. Okay, so any light here is going to bounce off the edge and come straight out. So that makes a good headlight. All the light is being shot straight forward. Does that make sense? Okay. It also works in the reverse direction. So signals arriving parallel to its axis are directed towards the reflector's focus. So if we have, like it says here, incoming radio signals, they're going to come in parallel to our axis of symmetry. They're going to bounce off the edge and aim at the focus here. Okay, so anything coming in is going to bounce off the edge and be directed to the focus. Okay, so a good example of this was you could put a microphone there. And so all the sound is going to come in and bounce to that microphone so you can hear it. All right, questions about that? All right, so our last example, bless you. It says, on the sidelines of each of its televised football games, the football TV network uses a parabolic reflector with a microphone at the reflector's focus to capture the conversations among players on the field. If the parabolic reflector is 3 feet across and 1 foot deep, where should the microphone be placed? Well, we know that the microphone should be placed at the focus, right? So the job here is find the focus. Now, where most students get hung up is that they think the dimensions that they're giving you are leading to that focus. How do I want to say that? Without any calculations. So when we normally graph a parabola, right? It keeps going forever. Okay? We've got a focus in here somewhere, and we've been using that focal width to help us determine how wide it is. Okay? But what they're showing us here is that they've got this parabolic reflector, a reflector in a parabola shape. But they are only giving us part of it. Okay? They're cutting it off there. That's the whole reflector. But it doesn't mean that these endpoints here are the endpoints of your focal chord. They're just the top of the parabola. Okay? So the focus is not necessarily in line with those points. It's somewhere inside that curve. Does that make sense? So do not assume it's in line with the top edges. Okay? All right, so easiest equations for parabolas were when the focus or when the vertex was at the origin. Yes? So if you can place your drawing so that the vertex is at the origin, it's going to make it easier. So that's what we've done here. We are looking at this parabolic reflector. We're going to assume the vertex is at the origin. And what they've told us is that the parabola shape is 1 foot deep. So the top edges of my reflector here are 1 foot above the x-axis. And they've said it's 3 feet wide. And because our parabolas are symmetric, and we've centered it at the origin, then 1.5 feet would go on either side. So this distance here is 1.5 feet. Does that make sense? But again, that is not giving you the focal chord, okay? That's just giving you the top of the reflector. But what it tells me is that any point on here, that x and y coordinate has to work in my equation, right? So I know that the point 1.5, comma 1 has to work in my equation for that parabola. So let's start out, is it x squared or y squared? That's your first question. Because it's opening up, okay, x squared. And we said we put the vertex at the origin so we don't have to worry about an h and a k value. And what we know is that when x is 1.5, y has to be 1, right? That's on my parabola. So if I put a 1.5 in for x, and I put a 1 in for y, I know it has to work. So can we figure out p from that? All right, 1.5 squared is how much? Good, 2.25 equals, and on the right side we just get 4p. Divide 2.25 by 4. We're going to do a little converting, so grab your calculators. Take 2.25, divide it by 4. What do we get? 560. Okay. Now, what units were they giving all these measurements in? They were giving it in feet. So that is telling me that if the top of my reflector is at 1 foot, okay, my focus is really at 0.5625 feet above that vertex. Yes? So about halfway up, a little over halfway up. What would that be in inches? Okay, what would we do to convert it to inches? What? Yes, multiply by 12. So take 0.5625, multiply it by 12. Okay, so we would want to place the microphone .75 inches above the vertex, okay, on that line of symmetry. Okay, so it would have coordinates 0, 6.75 based on the picture we have. Okay, so when you're given a word problem like this, if it's at all possible to put the vertex at the origin, do that. And then decide, is it a parabola that seems like it should open up or down, like a satellite dish would open up, okay? Or is it something that makes more sense, like a headlight to be sideways, okay? But again, put the vertex at the origin if possible. Questions? Okay, on our third day assignment here, notice that for question 63, I've changed the directions a little bit. I want you to find an equation for the parabola, okay? And then just find the height of the rightmost support cable. It's asking you in the problem to find all of the heights of the support cables. You don't have to do that. We're just going to find one of them, okay? So it's another case, it's a bridge situation where you're given this, okay? But do not assume that those top edges are in line with your focus. Your focus is down here somewhere, okay?